Okay, in this video I'm going to show you some examples of how to decompose an algebraic fraction into partial fractions. So in the last topic you would have been looking at algebraic fractions, and often if you're trying to maybe solve an equation or something, it's easier if you have two fractions like 2 over 1 plus 2x minus 1 over 1 plus x. You would be able to combine that into a single fraction by making a common denominator, and you could see that would end up as 1 over 1 plus 2x 1 plus x. Okay, so you would just multiply across and simplify, and you'll be able to do that. But sometimes you actually want to go the other way. So you would be given a fraction like this, or you would have a fraction like this for whatever reason, and you might want to change it back into these two, into this difference of two fractions. And that's what we call partial fractions, when we split up a fraction like this into two fractions like this. And in particular, this is going to be useful when you are integrating. It's much easier to integrate these than something like this. But for the moment, we're not going to actually do any integration. We're just going to do the decomposition. Okay, so whenever you do this properly, you'll end up with what's called a proper fraction, which means that the numerator will be of a lower order than the denominator. So here you can see the linear expressions on the bottom, and then it's just a number on the top, and that's what you want always. Okay, you want to end up with if you have a linear expression on the bottom, you want to have a number on the top. So let's do an example now. There are two different methods you can use for this, and it's completely up to you what you want to do, so I'll show you both. Let's start with this example, which is x over x minus 2 times x minus 3. So when you see a fraction like this, you know that when you're decomposing it, you're going to end up with x minus 2 as the denominator of one fraction and x minus 3 as the denominator of the other fraction. But at the moment you don't know what the top is going to be, so we normally just write a and b because we don't know what those numbers are going to be. And now this is actually an identity. Okay, so for any value of x, so long as we have the a and b there, the right numbers are for a and b, for any value of x, this fraction can be rewritten as the sum of these two fractions. So what we need to do is kind of work backwards. So if we were going to put this back into a single fraction, what would we do? Well, we would multiply the denominators by the opposite numerators. So we would end up with a x minus 3 plus b x minus 2. And that would give us something that was over x minus 2, x minus 3. Right, when we added those up. Now we know that this is the same as this, and this is the same as well, so that we can actually just look at the numerators now. So just looking at the numerators, we know they're the same. So a x minus 3 plus b x minus 2 equals, or always equals, x. So we're just comparing the numerators of this fraction and this fraction because we know they're going to be the same. Okay, so one way that we can do this is, because this is true for all values of x, we can substitute in specific values of x that will be strategically chosen to cancel out. So for example, we could cancel this out by substituting in x equals 3. So if we substitute in x equals 3, we end up with a times 0, so no a's, and we end up with 3 minus 2, so b equals, and then 3. So that was pretty easy, right? So now we know what b is. And then we want to choose a different value to get a. And to do that, we want this one to become 0, so we're going to substitute in x equals 2. and we're going to get 2 minus 3, so that's minus 1a, plus 2 minus 2 is 0, that's what we wanted, the b cancels out or goes away, equals 2. So minus a equals 2, which means that a equals minus 2. Okay, and then you can go straight back in and rewrite this identity. So x over x minus 2, x minus 3 is identical to minus 2 over x minus 2 plus 3 over x minus 3. And yeah, you would be done. Okay, so that was one method, is substituting in strategic values for x so that you sort of get rid of one of the unknowns and are just left with the other one. Another method is continuing from this step. So if we have, so method 2, we still compare the numerators, so we still have our ax minus 3 plus bx minus 2 is identical to x, but this time we're going to expand out. We're going to have ax minus 3a plus bx minus 2 equals x. Then just rearranging, gathering together the, sorry, that should be 2b there, gathering together the x's and the not x's, so we're going to have a plus b x minus 3a plus 2b is identical to x, and then we can compare coefficients. In this one, that's kind of a small thing, but we can compare coefficients. So we know that a plus b needs to equal 1 because the coefficient of x is 1, it's just 1x there, and we know that negative 3a plus 2b needs to equal 0 because there's no sort of number there with x. So that gives us a pair of simultaneous equations, a plus b equals 1 and minus 3a minus 2b equals 0. Then we would want to solve these perhaps by elimination. So if we name this equation 1 and this equation 2, we can multiply 1 times 2 gives us 2a plus 2b equals 2, and then if we add that to the equation 2, we're going to end up with minus a equals 2, which you can see is exactly the same as what we had before, so a equals negative 2, and then we can substitute that back in up here in 1, and we end up with minus 2 plus b equals 1, so b must be 3. And we end up with the same answer. Certainly in this instance, this one was way quicker, and oftentimes that will be the case, I think, but sometimes you will need to use this method, certainly for more complicated ones where there's more factors or where there's repeated factors. So that's to come, so don't let that scare you, that's coming up later. For simple ones like this, I would say this is the easiest method though, but it's completely up to you. So first method, substituting strategic values, and second method is just expanding out and comparing coefficients, and you'll get the same answer for both of them. So the answer to this, just to make it completely clear, the answer to this, the actual partial fractions that you're looking for, is this identity here. So this is where you've said the original fraction that you had can always be written as the sum of these two partial fractions. So that is the answer. So we showed two different methods, but that's the actual answer that you were looking for. Okay, so I'm going to do another example now, or another couple of examples actually. So another example, let's look at this. So if I wanted to change that into partial fractions, sometimes you will not be given some neat, nice brackets like we had before, but all you need to do is factorise first. So if you wanted to express this as a sum of partial fractions, you would first factorise the denominator, so this is going to be identical, and it's going to be 2 plus x 2 minus x. Difference of two squares, which is very common in these type of questions. So do keep an eye out if you have something that doesn't look like what you would expect. Check if there's a difference of two squares, because there often will be, or if you can factorize another way. And then this is going to be exactly the same as what we did before. So 2 over 2 plus x, 2 minus x. Right, now that's going to be equal to something over 2 plus x, let's call it a, plus something over 2 minus x, and let's call that b. Then what we want to do is multiply, so we end up with a, 2 minus x, plus b, 2 plus x, okay, and that's going to be equal to the denominator of this fraction, which is 2, okay. Now I'm going to use the first method here, so because I think I can see easily that this is going to cancel nicely. So if I sub in, okay, remember that's an identity, true for all values of x, so if I sub in x equals 2, that's going to cancel out a, right? So that's going to be 2 minus 2 is 0, a, then b, so 4b equals 2, so b equals a half. All right, and then if I sub in x equals negative 2, then I will get 2 minus 2, so 4a, 2 minus 2, that's going to give you 0b, which is what we wanted, equals 2, so a equals a half as well. All right, so it's perfectly fine to get a fraction, and the way you're going to end up writing that is always nice to start with your original fraction. Or maybe I should have written it as that, but it is the same anyway. Equals, and then we're going to have 1 over 2, 2 plus x, plus 1 over, okay, and you can write it like that. So that would be the answer for that one. I'm just going to leave it at that one method because that was just a second example. Okay, and now the third example that I'm going to show you is when you have 3 factors on the bottom. So the example here, we're going to start with 11x plus 1. It's going to be the numerator, and then we're going to have 3 factors on the bottom. So x plus 1, x minus 1, and 2x plus 1. Okay, and sometimes you are going to need to factorize this yourself, but in this instance it's given to us, and that's going to be equal to exactly the same, but this time we're going to have 3 fractions. So we're going to have a over x plus 1 plus b over x minus 1 plus c over 2x plus 1. And the method is going to be exactly the same. However, this time we need to be careful to multiply by both other factors. So if we're going to do that, it will be a times x minus 1 and 2x plus 1. That's what you would need to make it all over this. Then b would be multiplied by x plus 1 and 2x plus 1. And c would be multiplied by x plus 1 and x minus 1. All right, and that would create a fraction that was over the common denominator of x plus 1, x minus 1, 2x plus 1. Okay, which is what you wanted. And again, let's compare the numerators. So we've got a, x minus 1, 2x plus 1, plus b, x plus 1, 2x plus 1, plus c, x plus 1, x minus 1, and that is going to be identical to the numerator on the original fraction, so 11x plus 1. Okay, and again, both methods would work. We could expand all this out and compare coefficients. That would be possible, or we could try substituting in strategic values. We just need to be a bit more careful with it. So I'm going to start with substituting in x equals 1, because I can see that there's an x minus 1 is one of the brackets. So let's see what happens when we substitute in x equals 1. Here, that bracket is going to be 0, which means that whole term is going to be 0. So the a term is going to be 0. All right, now since we've got more, I'll write that 0 just to keep track there. Then looking at the b term, x plus 1, okay, well that's 2. Then 2x plus 1 there, that's going to be 3. And times by b. So that's what's going to happen to b. Then with c, that's going to be 2. But then 1 minus 1, that's going to be 0. So that whole term is going to be 0. And on this side, we're going to have 11 times 1, so 11 plus 1. So simplifying that down, we've got 6b equals 12. So b is 2. Okay, so we've got 1 of our numbers there. Now let's have a look. What else could I substitute in? Well, I could substitute in x equals minus 1. That might help with something as well. So let's look here. That's minus 2. And that's going to be minus 2 plus 1, which is minus 1, times a. Then minus 1 plus 1, that's going to be 0, so that term is going to disappear. Here again, we've got minus 1 plus 1, so that term is going to disappear. And then on the other side, we're going to have minus 11 plus 1. So simplifying that, we have 2a, because the negatives cancel there, equals negative 10. So a equals negative 5. And now finally we want to find c. So we're going to have, so what's the last one? We want to substitute in the negative 1/2, which will make that one 0. So that 2x plus 1 bracket 0, because 2 times negative 1/2 will be negative 1 plus 1, 0. So that a term will cancel. Here, the b, that's got that bracket, 2x plus 1 in 2, so that's going to cancel. And as we've hoped for, it's the last one that we haven't got yet. So minus 1/2 plus 1 is going to give you 1/2. And minus 1/2 minus 1 is going to give you negative 3/2 times c. Then 11 times minus 1/2 is going to give you minus 11/2 plus 1. Then simplifying this, we're going to have negative 3/4 c equals negative 9/2. Then multiplying that through, we're going to have c equals, so multiplying by 4, we're going to have negative 18, so minus 3c equals negative 18, and then c equals 6. Right, and then we've got all three, so we want to go back, write our original 11x plus 1 over x plus 1, x minus 1, 2x plus 1 is identical to, okay, let's make sure we get them in the right order, minus 5 over x plus 1 plus 2 over x minus 1 plus 6 over 2x plus 1. Okay, and that was 3 examples of how to decompose into partial fractions.